Hi Geometry, this is a video for the Chapter 9 practice test going through the answers. As you can see on the left of the screen, I have the questions. I might write some notes on the right as far as what we have here. So what we're looking at is triangle M prime, O prime, P prime, and triangle MOP, looking at how can we translate to get from one to the other. So a rule for this translation, remember that those are written as an XY and then an arrow, and then what's happening to X and what's happening to Y. Remember that anything that moves up or right is positive. Anything that moves down or left is negative. That's what we need to remember about our translation rules. So in this spot, we just put, okay, plus or minus how much. In this spot, plus or minus how much. So you can look at point to point. So O to O prime should be the same distance as M to M prime, which is the same as P to P prime. So if I start over here at O, I need to move 1, 2, 3, 4, 5, 6, 7 to the left. I'm sorry, to the right. So that would be a plus sign since I'm moving right, and a 7, that's how far right. From that spot, I'm going to move 1, 2, 3, 4, 5, 6, 7 up, and I'm going to do a plus and a 7 once again. So translation images, the rules are written here. If you have to do something like that again, it would be either this drag and drop situation on the real test or maybe some kind of fill in the blank situation as well. Okay, let's see what we have next. The next one, let's see, is a rotation and isometry. So the word isometry is the vocab there. That word means you have two figures that end up being congruent at the end. You get the same size and the same shape. So if you're talking about a rotation, you're talking about taking a square and you're rotating it. What you should get is an upside down version of that same square. So when you rotate it, you're not changing how big or small it is. You're not changing the fact that it's a square. So yes, a rotation is an isometry. So the question is it this yes or this yes? Well, the shapes are not similar. Similar means that they have different sizes, but they have the same angles. These have the same angles and side lengths. So I want the one that says size and shape stay the same. Third question is asking us to do a bunch of transformations on a graph. Expect something like this tomorrow as well on the real test. It says complete the following translations of the point 4, -3, and it says we're starting over with 4, -3 each time. So it's not a situation where we have to take the point and whatever our answer is for A, that then we do something to that for point B. None of that's happening. We're starting with the same point every time, which is 4, -3, so I'll put a dot in that place on the graph here at the right. Okay. Remember when we're reflecting over the line x equals 0, this is something that gets messed up a lot, so be careful with it. What we want to do is we want to take x equals 0 and remember that that is the y-axis. That's this line here. Okay, this is the line x equals 0. So the y-axis is the line x equals 0. A lot of people by mistake we'll use this line and think that's x equals 0, but that's y equals 0, so we don't want that one. Okay, so x equals 0 is the line there in red, so I just need to figure out how far I am away from that red line, so how far this distance is. All right, it's 1, 2, 3, 4, so I'm going to do 1, 2, 3, 4 and put a dot there. So there's a way to do these via a rule, and there's a way to do them via the picture. So if you reflect over the line x equals 0, the rule for that, again, what's going to end up changing, my new spot right here can help me figure out what the answer is. -4, -3 is where I landed. That's the one that I want to put here for my answer. Okay. The rule for that would have been to take the xy, all right, and then just change the x, the opposite of x, and then keep y the same. All right, either way, I could have done the same thing. I could have done this with a picture or without. So I'll come back to the graph here in a second, but I'm going to go through these with the rules because that might be a little bit nicer for us since we are looking at maybe not having graph paper tomorrow when we take the real test. So I'm going to look through and I'm going to say, I'm just going to remind myself, I'm always starting with the point 4, -3. All right, this one I'm going to rotate 180 degrees. So if I want to do a 180-degree rotation, okay, it does say counterclockwise. 180 is the same counterclockwise and clockwise, so there's no way to mess that up here. All right, but with the rule, what we do, any x, y is going to turn into the opposite of x and then the opposite of y. Now notice how I'm not saying negative x, negative y. The opposite of x this time, x is 4, the opposite of x is -4. Okay, then the opposite of y is 3, so the opposite of y will be -3. Okay, or sorry, -3. The opposite of -3 will be +3. So my answer here is -4, +3. So let's see, right here. Oops, that's the one that says -3. -4 and a +3. There we go. Okay. All right, the reflecting across the x-axis. Okay, well, we're going to take our 4, -3. The rule for that, the x-axis, what we're going to do is we're going to take any x, y, flipping over the x-axis, that's this line this time, okay, which is the same as y = 0. But what's going to happen is any point is going to flip just vertically and not horizontally. So what's going to happen there is the only thing that's going to change is the y term. We're taking the opposite of y, we're keeping x the same. So like we said, we're going to keep x the same. We're going to take the opposite of y, the opposite of -3, which is +3. So instead of 4, -3, we're going to land at 4, 3. Okay. Next one wants us to take the point 4, -3 and see where it lands when we reflect over y = x. Okay, well that one, just to look at that line, that is the the positive line going up a slope of up 1 over 1. Okay, that's that line here. Y = -x would be coming down this way. Okay, but we want y equals, we're talking about y = +x right here. Wrote down the wrong thing. Okay, so we're going to reflect over that line. So when we do that, we're going to take x, y, we're going to reflect it by switching the y and the x. Okay, so that one's a kind of a weird rule, but what ends up happening is we take the y, we leave it the same, so it was -3 to start with, so we're going to keep it -3, but we're going to put it first, and then we're going to put 4 for our second answer, or for our second point. So our answer will be -3 with a +4. Okay. Let's see. We have 4, -3. This time, we're going to see where it lands when we rotate 90 degrees counterclockwise. All right, so 90 degrees counterclockwise, we take our x, y, we reverse them, and we take the opposite of y. So we leave x the same, we put that second. So the rule is there. So we need to take the opposite of y, which the opposite of -3 is +3, and then we need to take the y term, or the x term, leave it the same, and put it second. Put it as the y term. So +3, +4 will be my answer there. Okay. We should go back to the graph for this one. So when we look at a line that says y = -1, we're reflecting over y = -1. As soon as there's a number there, y equals a number or x equals a number, we no longer have a way to just do a rule every time. So I'm going to start by putting my point on there, 4, -3, and then I need to draw that line in. I need to draw the line y = -1. Well, y = -1 is this line right here. Okay, that's y = -1. Okay, so y = -1 is a horizontal line. So now I just need to look at my blue dot, and I need to move it up 2 to get to the red line. So I need to move it up 2 more to get my final answer here. So this has an answer of, I still have 4, that didn't change, okay? But now I'm only up 1. So my answer there is 4, comma 1, okay? And then the last one, this is doing 2 in a row. So let me go back to not using the graph paper. I'm going to start with 4, negative 3. The first thing I'm going to do is reflect it over the y-axis. Okay, so when I do that, the rule for that, I'm going to take, and I'm going to flip and take the opposite of x and keep y the same. When I do that, the opposite of x is negative 4. Okay, and then I'm going to keep the negative 3 the same. So that's the answer after my first transformation. I'm going to do that followed by something else, followed by a 90 degrees clockwise rotation. So over here, I'm supposed to go 90 degrees clockwise, which is the same as 270 degrees counterclockwise. So what that means for us, the rule, we reverse them, but we take the opposite of what x was. Okay, so I'm doing that rule to my second term right here. So I'm taking the opposite of x, so the opposite of 3 is negative, or sorry, the opposite of negative 3 is 3. Then I'm keeping x the same. Oops, I'm sorry, I was doing the wrong rule. We're keeping y the same, so y is going to stay at negative 3. And then we're going to take the opposite of x, the opposite of negative 4, which is 4. So this one has an answer of negative 3, positive 4. Okay. So that one's done. I'd be ready for something like that tomorrow. Okay. Remember these rules now. They should all be written down somewhere. Your note card would be a great place for it. They want, what is the rule for reflecting over x equals 0? Remember, we've talked about that. That is this line right here. Okay, this is the line x equals 0. Okay, so what happens with any point is they're going to just move the same distance away to the opposite side of the line. So what's going to change is our x terms. What's not going to change is our y terms. So our x is getting flipped to be the opposite of what it was. Y is staying the same. So opposite of x, keeping y the same. Negative x, positive y. Okay, so regular hexagons. You can try to draw the hexagon in if you want. All right, it might not be hexagon tomorrow, though. It might be decagon or dodecagon or heptagon, whatever it is. With these, and you're talking about lines of symmetry, you're talking about how many ways can I cut this perfectly in half so I have two things that are the same size. So I'm missing a couple here. One here and one here. So this is a total of 1, 2, 3, 4, 5, 6 lines of symmetry on this hexagon. Well, the key wasn't to draw it. The key was to know how many sides that has. A hexagon, n equals 6. Whatever this number is going to be the number of lines of symmetry that that shape will have. So if it says regular triangle tomorrow, the answer would be 3. Okay. Over here, it's asking what types of symmetry do these shapes have. So just going through here quickly, I could do a line right down the middle of the Snapchat, but I can't rotate it to have any symmetry. It won't look the same if I turn it. So this one just has line symmetry. This target symbol definitely can rotate. If I turn it even just a little bit, it'll look the same. And I can cut it in half pretty much anywhere that goes through the center. So this one is going to be an example of having both. And then our recycle symbol does not have line symmetry because of these arrows. If I look at trying to make a vertical line right down the middle of one of these, then this arrow would kind of end up over here, which wouldn't look the same. All right, so it won't have that, but you could take this and rotate it. You could take it and turn it to a point where it would look the same. It's going to look the same every 120 degrees. And this one, you could do a line right down the middle, vertical or horizontal. And you can turn it upside down and have a 180 degree rotational. So this one has both. Okay. This is going back to rules again. So the thing I would point out is anything with apostrophes over here, this is the after. So this was the before, this is the after. So I'm moving left, X is moving left, and y is moving up. So we're going to have a negative and then a positive, a negative x and then a positive y. So if you want to put those in right away, you can feel free to do so. To get from A to A prime, it would be left 1, 2, 3, 4, 5, 6, 7. So it's 7 again. And then up from there, 1, 2, 3, 4, 5, 6. So it looks like minus 7 and then plus 6. Okay. With these ones, there's not too much to worry about. We're looking at what type of isometry could we get to take this dashed one, this solid one, and make it land on the dashed one. So I could translate that one over. That would be an okay answer there. Okay, but that's not the only answer that's acceptable for this one. I could also do a reflection on this vertical line right here. So I could have put reflection there. Okay. Technically, you wouldn't be able to rotate it side by side like that. So this is going to be as good as we can get. So reflection or translation, either one of those would have been fine. And then down here, this one's going to have to be translation, since a slanted line of reflection there wouldn't make this one land on this. It would, if I put a diagonal line here, it would land somewhere down here. Okay, so this one can be either or. This one has to be translation. All right, so this one is just saying going backwards. So if I have a translation rule that says we're moving to the 4 to the right and 5 down, they want to know, what is that backwards? Well, that backwards, if I want to figure out where the point was to begin with, I'm just going to take the opposite. So instead of going 4 to the right, I'm going to go 4 to the left. Instead of 5 down, I'm going to go 5 up. So I'm going to take x minus 4 and y plus 5. Okay. Let's see. Isometries, we've talked about these a couple times now. All right, remember that the isometry, we have the same size and shape. That's what we should think of when we see that word tomorrow. Same size and shape. So the pre-image is a reflection of the image. That's true sometimes. Reflection is not the only isometry though. Pre-image is smaller than the image. That cannot be true. Okay, and we're looking for what is not true. Okay, the pre-image should not be smaller than the image, because then they would be different sizes. Okay, this one says, so that's going to be our answer. The pre-image and image are congruent. That's true. The pre-image and image have the same orientation. That's another one that's sometimes. Okay, so we have a couple. This one's kind of a poorly worded question. This one's the only one that's definitely not true. Okay, this could be true if it's a reflection. This could be true if it's anything but a reflection. Okay. All right, so this one now, they're going to start giving us some things here. They're saying that we have a triangle GUS, and they give us those points. They want to know, how do you get from G to G prime? Okay, they're asking, how do you get from G to G prime? Well, G is at 3, negative 4. All right, and it landed on negative 1, positive 2. Well, they want to know, how do you get a rule that gets 3, negative 4 to land on 1, negative 2? So the first thing I'm going to do is I'm going to look at these 2 points, and the way to get from 3 to negative 1 would be to subtract 4. The way to get from negative 4 to positive 2 would be to add 6. So that's going to be the rule. Now I'm going to use that rule to get from S to S prime. So S is at 0, 2. I'm going to do the rule on S prime, which is subtracting 4 and adding 2, which is negative 4, positive 8. So negative 4 would be my X, and positive 8 would be my Y. Okay. Let's see, we have BAT having coordinates of, you can read those. If a triangle is reflected over the line x equals 1, what are the coordinates of the A prime? So I'm going to go back to the graph for this. Here's the point A, which is, because we're looking for what's A prime. So I'm just going to draw A in there. It's at negative 4, positive 2. So there's A, right there. Okay. They want the line x equals 1. That is a vertical line, just like that. Okay. So if you get a question tomorrow with an x equals 1 or y equals 1, you might want to have some graph paper handy so you can give that a quick sketch. Okay. To get from A to the line, it's moving 1, 2, 3, 4, 5 steps over. So I need to go 1, 2, 3, 4, 5 steps over. And there's my A prime. So A prime has an answer as far as 6 to the right and 2 up. So it moved all the way over to 6, and then we ended up at 2. All right, now we're doing the line y equals x. You can do this on a picture. You're more likely to just use the rule tomorrow. So I want to know what h prime is. Okay, the rule for y equals x. The rule for y equals x is going to be to take your x, y, and reverse them. Okay, so h is at -1, 6. That's going to land on h prime of 6, -1. We're just flip-flopping them. So 6, -1. All right, so with these ones, we have to remember that if something gets bigger, then it's an enlargement. If something gets smaller, then it's a reduction. So this one, if you can look at this side over here, okay, the small triangle is the before, the blue triangle is the after. So since the small triangle is the before, that means that this was an enlargement. The triangle got bigger. Since that happened, all right, we're going to go from where we started to where we ended up. So the scale factor for this to get from 3, well, we got to be careful here. So let me give that a quick sketch. If this is the big triangle, okay, x prime, r prime, t prime, this has a length of 12. Now, if you don't know where I got that number, all right, this piece is the small triangle. This was 3 and this was 9. So I needed to add those 3 together, or add the 3 and the 9 together to get the 12. So how do I get something, how do I get from a side length of 3 to a side length of 12? Well, that would be to multiply by 4. So if you say it's an enlargement, this should be a number bigger than 1. If we would have said reduction, which I think we have coming up, it should be a fraction. Okay, so you might have put 3 instead of 4 because you might have thought 3 times 3 gives you 9, but this whole thing is actually 12. Okay, all right, angles of rotation. Point X is the center of the regular hexagon BLAINE. What is the measure of the clockwise angle of rotation that will map L onto M? So first off, there's 6 sides. We take 360 divided by how many sides there are to figure out how many degrees each letter is away from each other. So each step is 60 degrees. So now we have to go clockwise, which is going to be this way, to see how many steps from L to N. Well, it's 1, 2, 3 steps. So we're doing 60 times 3, or this is a 180 degree turn. So this is 180 degrees. You don't have to type in the degree symbol. Okay, same problem, but now we're going to do counterclockwise, and we're going to do 240 degrees. So 240 degrees counterclockwise. All right, so I'm just going to get rid of this piece here. This isn't what we need anymore. All right, each step is still 60 degrees. All right, so if I take 240 divided by 60, that'll tell me how many steps I need to take. Okay, so I want to start at X. I'm going to start at A right down here, and I'm going to go counterclockwise this time. All right, so that would be this way. Okay, this direction, going the opposite way a clock would go. So from A, I'm going to go 4 steps. 1, 2, 3, 4, and I'm going to land on B. All right, again, this is 60, 120, 180, 240. All right, and make sure you went counterclockwise. This direction is clockwise. Okay. All right, these ones should be pretty quick. They're just testing your multiplying skills. All right, this number here is the scale factor. So I'm taking this scale factor and I'm multiplying each number by it. So 3 times 3 is 9. -1 times 3 is -3. -4 times 1/2 is -2. And -6 times 1/2 is -3. Okay. All right, here's another one with enlargement or reduction. That's the first question. It says the one with apostrophes is the image. Here's the one with apostrophes. It's smaller than what I started with, which means this is a reduction. The scale factor, what I would do is I would just count a side that's easy to count, like the bottoms here. Okay. The distance from G to U is 1, 2, 3, 4, 5, 6, 7, 8. Okay. The distance from G prime to U prime, so the other one that's on the bottom, is 1, 2, 3, 4. So the question is, what do I have to multiply 8 by to get to 4? I would have to multiply by 1/2. So this triangle, G prime, R prime, U prime, is the result of a 1/2 reduction on the original triangle, GRU. Okay. Let's see. A microscope shows you an image of an object that is 15 times the object's actual size. So the scale factor of the enlargement is 15. If a cell is 1.2 centimeters long under the microscope, what is the actual length? So I need to take this 1.2 and decide if I should multiply or divide by 15. And that's going to be my question there. So what it's saying here is that this is a cell that's this length under the microscope. That is an enlarged picture. That's the after, and we know that the microscope is making things look bigger than they really are, which means in real life, it's going to be smaller than that 1.2. Right? So 1.2 divided by 15 will give me my answer. If you do that, it's 0.08. So it looks like I should have put the centimeters after, but I forgot to do that. You don't have to type that in. Okay. For which transformations do the image and pre-image have the same orientations? Okay. This just means that they're not backwards from each other. So if I reflect the number 7, okay, if I reflect the number 7 across this line, I get a backwards 7. Okay, so those have opposite orientations. So that wouldn't happen if I translated the 7. Okay, it wouldn't happen if I rotated the 7 so that it's just an upside down 7. Okay, what's happening here, the only thing that's going to flip the orientation is a reflection. I'm sorry, select all that apply, so I read it wrong. So these are all the ones that would be my answer then. These are all the ones that have the same orientation. All right, how to get from this heart to this heart? It's flipped upside down or it's rotated, okay, 180 degrees. So this one arguably has two good answers again. All right, you could rotate right on this point or you could reflect. So that one you should have both possible answers there. And then find a translation that has the same effect as the composition. So last one, okay? Composition means we're going to do two translations in a row. So the first translation is +3 for the x, -1 for the y. All right, then the next one is -1 for the x and +5 for the y. So what's going to happen there is if I'm doing a composition, I'm going to combine. Think of those two things as the same thing tomorrow. All right, so I'm going to combine those two. If I go 3 to the right and then 1 to the left, 3 plus -1 is +2. If I go 1 down and then 5 up, -1 plus 5 is +4. So that is where I ended up, and that's the same as doing those two translations back to back. So y plus and 4. All right, that should be it. Feel free to go back and watch anything that I didn't talk about in detail, or feel free to contact me with any further questions.